everything you'll need to know about the waves required practical for your physics paper 2. Let's get it. The purpose of the practical is to measure the speed of waves. For that, we use this equation. Speed is frequency times wavelength. So all you really need to do is find the frequency and the wavelength and then times them together. And there are two parts for this. You need to do it both in water waves and in a solid, in a string. Let's first focus on the water. Set up your ripple tank, which looks just like this. It's effectively a transparent topped table with some water in it. There needs to be a vibrating bar which dips into the water to generate our waves. And we have a light source above the ripple tank so we can clearly see the shadows of the waves on the screen below. And it's then using those shadows that we will measure our frequency and our wavelength. Frequency of a wave is how many waves pass a point in a second. So are you just going to sit there with your point of reference and count how many waves pass that point in just 1 second? No, that would be extremely inaccurate, a massive margin for error. Instead, we have our point of reference beside the screen and we record a video. Using that video, we'll count how many waves pass a point over a longer amount of time, something like 10 seconds, for example. We can then simply divide that number by 10 to give us a much more accurate estimate of the frequency of our waves. So record a video, count waves for 10 seconds, divide by 10. For the wavelength, it's a pretty similar way of thinking. Are you just going to sit your ruler there and attempt to measure? No. Place your ruler beside your screen, take a picture, and then from your picture you can measure the distance of 10 waves and divide by 10 to get your single wavelength. We don't just measure one because that leaves a massive margin for error and it's not a very accurate way of measuring your wavelength. If you've managed that, you've got both your frequency and your wavelength, so you literally just times them together and you've found your wave speed. The other part of this practical is doing the same thing but in a solid, and for that we use a string. Set it up just like this. We need a pulley with some hanging masses to give us tension in our string. We need a vibrator. We adjust that vibrator or oscillator until we have a nice standing wave pattern. Now be careful, you may be given a diagram of a standing wave pattern, something like this. Consider exactly how many wavelengths each of those little loops in your standing wave pattern actually represent. Remember, one full wave cycle is until it begins to repeat again. So on a standing wave, every one of those loops that you see is only half of the full wave, half of a wavelength. There have been questions in the past where you've got to calculate wavelength from a diagram where you've got, say, 1.5 wavelengths. So just be careful. But anyway, we've done the hard stuff. Set up the apparatus. To get your frequency, you literally just read it off of your vibrator or oscillator. And to get your wavelength, place your ruler beside your standing wave pattern, measure as many as you possibly can and divide it down to get your single wavelength. Remembering that each loop is half of a wavelength. And then Bosch used this equation, V equals F lambda, again to calculate your speed by timesing together frequency and wavelength. For this string one, you could repeat it for different harmonics, so different standing wave patterns. Doing that would increase your reliability. And with that, we've smashed it out of the park. The things that normally come up with that is making sure you're taking accurate measurements, measuring 10 wavelengths divided by 10, that sort of thing. If it comes up, you're now going to smash it because you've watched this and you've got everything you'll need to know. Save it so you can watch it again before physics paper 2. And if there's anything else you need a hand with,